Hi guys, my name is Tushar and you're watching the Wayland Band Techie Talk. This is a new platform where we are going to discuss about new technologies and implement them through these videos and try to pass our knowledge to our viewers. So in our first video, we are going to discuss about Docker and do some action on it. So first, let us know what is actual Docker. What is Docker? Docker is a set of platform as a service products that uses OS level virtualization to deliver software in packages called containers. So this is a very techy statement, but in layman language, it is a service that you can download and install over your system like Windows, Mac and Linux and create separate containers for each application you want to run as per your requirement. What is container we'll be discussing in next slide, but for now remember this that Docker acts like a middleman between the host OS and the applications you want to run as per your requirement as separate container. Well, you might be comparing it with virtualization tools like VirtualBox and VMware, but no, it is not a virtualization tool, it is basically a containerization tool. So what is the difference between containerization and virtualization? So guys, in the case of containers versus virtualization, we have two images over here. So in the right side we have virtualization. So in the case of virtualization, we have host server beneath, which is a combination of all the physical resources like RAM, core and storage management. And over that we have operating system like Windows, Mac and Linux, and over that we can install softwares like hypervisor, VirtualBox and VMware, with which we can create new VM. And over here we have VM1, VM2, VM3. So in the case of this we can see we have 3 VM, and like if you see on the upper level we have application MySQL and MySQL. So in this case we have 3 VMs with one VM1 as an application running on it, and on the VM2 and VM3 we have MySQL applications running on it, and each of the VM has their own virtual OS, and each virtual OS is a combination of its own virtual kernel and all the application and libraries, and with which we also have a physical requirement for that. So we have to provide a certain amount of core, RAM and memory to each VM, making it a very heavy system. Now in the case of containerization, we have a host server over which we have an operating system, and over which we have a containerization engine like Docker, which helps us to build containers. So in the case of containers, it is much different from VM, as in the case of VM, we have to dedicate a certain amount of asset or resource to each VM, but in the case of containers, we can basically share resources between the different containers. So see, let us take a scenario. We want to create 3 separate containers of Nginx, MySQL server and Redis server. They might require a similar Linux OS configurations to run. So when we create a new MySQL container, it will download all the files related to the OS and other binaries to run the particular application. And after that, when we try to create containers for Redis and Nginx, it will not download the files related to the OS, but instead it will be sharing the resources with the MySQL containers, making processing more efficient and reducing process time and infrastructure cost. So in short, virtualization, we need to require specific asset and resource to particular VM, making it a heavy resource. And in the case of containerization, we are basically sharing resources, which is a more efficient way. Now, what is container? As per definition, a container is a standard unit of software that packages up code and all its dependency so the application runs quickly and reliably from one computing environment to another. A Docker container image is a lightweight, standalone, executable package of software that includes everything needed to run an application: code, runtime, system tools, system libraries, and settings. So this is a very techy statement again. So guys, before going into know what actual Docker container or container is, you should know about what is actually a Docker file. So guys, if you want to create an application like Facebook, you need to have a source code for that, and to run that particular source code you should have a particular software to run and build the code. And to have that software you should have some particular application and binaries to download and install the entire software. And to run it, to install the particular software, you must have a particular based OS. That means to even deploy or create a small application to a big complex app like Facebook, you need to have certain configurations to run it. And to that we have to have a basic configuration page or script to be there. So over here Docker file is basically that. I'm going to take a new slide where you can see what Docker file is basically. So guys, over here there is a Docker file example, and this Docker file will create an Nginx web server on a base Debian OS. So guys, as you can see on the 6th line over here in the Docker file, you can see from Debian stretch slim, over which it says that our base OS image is Debian. So we are going to take Debian as our base OS. And on the 11th and 12th line we have defined our environmental variables like Nginx version over there with the 1.13.6-1 stretch. And over on the 15th line we have provided certain commands like run apt get update to the 33th line of and apt get install and all the Nginx modules. And on the 40th line we have exposed 4 ports of 80 and 443. So guys, this entire script is basically a type of text script with an extension called .docker file, and over which you can define all the entire configuration to run a specific application. This is a Docker file. This is called a Docker file basically, and you can build it using Docker. And once you build the entire Docker file, you get a Docker image over here. And after that, when you run this image, it finally gives you a container, which is actually a run form of this Docker image. And this Docker image is a build form of this Docker file. It's basically a file consisting of all the configurations required to run the particular application, like a simple app to an app like Facebook, to an Nginx web server, to a MySQL server, or anything. So that is how container works, and that is how Docker file is like the starting point of a container. And that is how we have covered the entire thing of Docker, Docker container, Docker image, and Docker file. So guys, that was much of a theory session. Now let us do some small practical and understand these concepts very fast in terms of practical thing. So you can play with Docker in two ways. Either you can install Docker into your own system, or you can go to this online platform called Play with Docker. By clicking on start, you will get to this platform where you can create new instances, where in which Docker will be pre-installed, and you can create new containers. Over here you can see there is a session which has been started now of 4 hours. So in this 4-hour session you can create n number of containers and all, and you can perform a task work and all. But after the 4 hours is completed, all the data that you have worked or created will be deleted. So this is not a reliable source to learn and create your own task. So I would rather ask you to install this toolbox or Docker desktop onto your system. If you're working on a Windows version before 10 like 8.1, you have to install Docker toolbox on Windows, which is a toolbox kit of Docker to work and install Docker onto your system by using VirtualBox as a reference to create a Docker VM on which you can play Docker. Or if you're on the latest version of Docker, you can just type Docker for Windows or Docker desktop for Windows, where very easily you can just install the entire service and you can play with it instead of creating a new VirtualBox and all every single thing. And if you're working on Mac, you can just directly type Docker for Mac and get all the required files and all. And if you're working on a Linux version, you can just typically go over here and get all the commands to download and install Docker into our system. Let us check whether I have Docker installed or not. So for that, I have to type Docker in my system. As I type Docker, I get this particular menu, and this resembles that I have already installed Docker properly. If my Docker would have not been properly installed, it would have showed me Docker command not found. So guys, now we get back to our task. So our today's task is just to create two containers with the same image of Ubuntu. So for that, we have to get an image of Ubuntu and run two containers. So I've already told you that a Docker container is basically a runtime form of a Docker image, and Docker image is basically a form of a build form of a Docker file. So for that, I'll directly go to this link called Docker Hub, which is a type of a hosting services where you can host your image and all like that. All the official images are being hosted over here. So if I go to Ubuntu, type over here Ubuntu over here, so I can get the official image of Ubuntu which the official team of Ubuntu has provided. So let me just click on this source. So if I go here, you will get all the original documents about the Ubuntu, like what is Ubuntu and what is in the image, and you will get all the license related stuff and every single thing into this area. Now over here you can see we have different tags and version of this Docker file, and if I build this Docker files, I'll get a new image of it. So let us type on the 18.04. If I click on it, I'll get the actual Docker file of this Ubuntu image. So see, this is the Docker file for my 18.04 version of my Ubuntu, and if I build this Docker file, I'll get the Docker image of it. So guys, let us just take this image by typing docker pull Ubuntu. So guys, let us just do docker pull Ubuntu. This will download the every layer of the image locally. So as you can see, it is downloading the entire image in the layer form. Okay, so as you can see, the entire image has been downloaded. Now we will just run a container of this image. The command for this is docker container run -it, where -it resembles interactive. This gives an interactive view of the container Ubuntu. Now let us give a name to this container called Ubuntu 1, and with the Ubuntu image name is Ubuntu. Now by this, see how fast this new Ubuntu environment has been created with the help of containerization. Okay, let us create a small change by creating a new directory called project, and let us just give okay. So the new repository, no new directory has been created, not project, and let us just exit it and create a new container called Ubuntu 2. Okay, and great. So now we have created two containers of name Ubuntu 1 and Ubuntu 2 of the using same image called Ubuntu. Now just type docker container ps. As you can see right now, all the two containers have been exited. Let me just start again. Docker container, basically docker container ps gives you the list of containers that are currently active. So just start, let me start it again, start this one and then this one again. So just fine, as you can see both the containers are running right now up for me for 12 seconds to 4 seconds. These both Ubuntu 1 and Ubuntu 2, these are two containers that we have created with the help of our Ubuntu image. And again, I'm telling you, these two containers are the runtime of the Docker image called Ubuntu, and that Ubuntu is basically a build form of that file that we have seen over there in our Ubuntu on Docker Hub. And that is how these basic commands work, like docker pull and docker container run.